1, 2, 3, 1, 2, 3.
Hello, good afternoon. The session is started. Martin, Agatha, can you hear me? Martin? I see you there and you are not muted. I should be able to hear you. Agatha?
1, 2, 3.
Martin? Martin, can you hear me? Martin? Martin, can you hear me?
1, 2, 3.
Martin?
Anybody hear me?
Yes. Yes,
hello.
I can hear you.
There we are.
Can you hear me?
I can't hear you.
That's weird.
You're not muted, but I can see your lips moving, but I can't hear you.
Okay. Anyway.
And I can't share my screen either. I can see your hand signals, but that's it. I can't share my screen. No one sees your screen show. Ah, right. Is that working? Okay, let's see if that works. Right. Okay. I hope you can see that. If somebody could indicate, that would be really helpful.
Yes, Martin. Martin, we can see you.
Hi, I can see you, Ian. Can you hear me? Can you see my screen? Perfect. I love it. Fantastic. Great sign language. Perfect. Very clear. Okay. Thank you, everybody. So, welcome to the second session of Ethics by Design for Data Technologies and AI. So, my name is Martin De Hever, Director of the Observatory for Responsible Research and Innovation, based in the UK. But we do work across Europe and also part of the PREFET project. I'd also like to introduce Agatha. Agatha, are you able to talk? I can't actually see you because. Right. Just bear with me a second. Apologies to the audience. We're just trying to just coordinate a little here. Okay, Agatha, I've just put a note in the chat. I just wondered if you wanted to have the opportunity of introducing yourself. Okay, perfect. Let's see if I can unmute you. I might be able to do that. I don't know if I can. Let's just see. Yeah, thank you, Manu. I saw the comment then. So I've tried to make Agatha like presenter. I think you can only have. So you're in my system. You're down as an organizer. I can see you as an organizer, which must mean you can speak. Okay. All right. Shall I press on? Would that be the thing? And then if we could maybe in the background, if we can sort that out. I'd like to give Agatha the opportunity of introducing herself. She's obviously a very important part of the team. Okay, well, so no more ado, here we go. So this is the agenda for day 2. So having introductions now, we've tried that, and we may have to delay the other introductions for later in the event. We have Agatha Gurskov from Trilateral Research, who's an expert in responsible innovation and many other things. Introduce myself, and later on we'll be delighted to have a presentation by Professor Philip Bray from Twente University, who will be talking about ethics by design for AI and the work he's been doing on the Sienna project for that. So first of all, I'll talk a little bit about some issues that we'd like to cover today, and then we'll have a bit of a discussion. Hopefully Agatha will be able to join us by audio at that point. We'll go on to Philip's presentation, and then we'll get into more of a plenary discussion about how ethics by design for AI could be considered to apply, first of all now, but also to a much wider range of technologies than just AI. So that's the premise for today. So I've done introduction, sorry about that. So we've covered this title as well. So first thing to say, I think, is that it's very difficult to go anywhere in this world without coming across some discourse about ethical AI. It does seem that everybody, one way or another, is involved in trying to come up with some guidelines for how we might address concerns around the development and application of things like artificial intelligence. But of course, that's a very broad church indeed. Is it general purpose AI, which is really quite hard to achieve, or is it very narrow or augmentation like AI, which may even be with us already? It probably is. So, but there's a huge discourse going on around that, and I've just given a few examples here, but I could cover the page with hundreds of different initiatives in this area. The European Parliament has done work on this. There is a high-level expert group in AI that has produced some guidelines. We'll actually be going into a bit of detail on that a little later on. We have some notable figures such as Elon Musk, who have been involved in funding and also had some fairly strong opinions on how we might mitigate issues around AI. Those issues include and approaches include the development of brain-computer interfaces. You may have seen this business that is launched called Neuralink. One of their use cases and their justifications almost for this highly invasive brain-computer interface is the fact it could be used in a symbiotic way to effectively allow humans to control AI. I mean, that's quite a big ask, and of course would require every system to, in some way, to be connected to a human. So it's a pretty tough one. And then the IEEE, amongst many others, have come up with ethically aligned design around artificial intelligence. So there are so many out there, and everybody seems to have a view. But from where we sit in Orbit, and also I think in PREFET as well, we see these initiatives, and there's more energy and money and thinking going into this than almost any other area of technology ethics. But none of this seems to be yielding. There are guidelines and there are targets and there are objectives, and some approaches are being proposed, but nothing really is being driven home too much. And I think because people see the general purpose AI as being some way away. So the thing is, of course, is that artificial intelligence is not, again, is a very broad church, but also can be considered to include many different enabling technologies. So I've given a few examples here. This is from an MIT paper, I've given the reference at the bottom. So there are data conditioning sides, so there's data curation, data labeling. So there are elements there in terms of the data quality and data bias and what have you. And even the curation side in terms of sensors, in terms of collecting data. All this information can be fed into learning systems or data sets for trying to understand the world, for example, using a wide variety of mechanisms. So these are all potential components of a future AI, but these things are with us now, as is the mass data collection from online sources as well, which is structured, some is unstructured, but very little of it exists without any kind of inherent bias because it comes from humans. So we have machine learning approaches, we have end users, we have all sorts of hardware technology that enables these things to be implemented through from traditional Van Neumann style CPUs to more focused GPUs to TensorFlow processing units that are a bit more machine learning oriented, neuromorphic computing that we discussed yesterday, which has myriad of applications, but initially seems to be quite a lot around computer vision, custom, so what we call ASICs, so application specific integrated circuits, and maybe in the fullness of time, or maybe now, depending on who you listen to, things like quantum computing for optimization, using things like Shaw's and Grover's algorithm, if indeed that ever works, or in combination with conventional machines. So all of these are potentially part of some future AI, but they're all with us one way or another at the moment. These things already exist. And in fact, if we are looking to consider the components that might form a future AI that would require the kind of governance that everybody seems to be terribly excited about, these things are actually with us already. These things already exist. We don't actually know for sure whether these will actually form part of a future general purpose AI, because of course that design has yet to unfold. But nevertheless, there are components there, and it seems likely that they at some point will form part of at least an attempt at general purpose artificial intelligence. So it's something that we do need to be considering now, very seriously, in fact. So next slide. So here are a number of approaches to what they call robust AI. Again, I've just taken one example here, but there are many different approaches. So the idea that any system or components of a system, and I would wish to emphasize that point, need to have the ability to explain themselves. Some would say that GDPR, General Data Protection Regulation, has within it the explainability clause, which does encourage those producing automated systems to make those fully explainable should there be no human intervention. So that may be an attempt at what they call anticipatory governance, but it's yet to prove itself worthy for the task. Metrics as well, how do we measure the inputs and outputs of systems and in order to try and understand their behavior. Validation and verification, so there have been traditionally approaches like formal verification for the testing of systems and the testing of algorithms, but when a technology has the ability to adapt to its environment, formal verification becomes really quite difficult because you don't necessarily have specific scenarios, specific use cases. It may be responding to the world in a novel way. In fact, that's a characteristic of adaptive systems that is seen to be appealing. So how can you test for or validate or verify a system against a scenario which is yet to emerge? So DARPA is doing work on this, DARPA in the US, on what they call formal verification of adaptive systems, that they have an approach to that where a level of autonomy is allowed, but there are some hard countermeasures required when activity becomes problematic. Security is another thing. It's all very well to be using data tools and algorithms and systems for the development of technology, which may form part of AI or may not, but they do need to be secure so that people are not actually poisoning the data sets. We talk about data poisoning, but equally attacking the system in some way in order to affect its activity. And then down at the bottom here, we talk about policy, ethics, safety, and training. So these are with us very much at the moment, but are they actually really being applied to the components of AI? I suspect not always, or in a rather patchy way. So if we were to think more deeply about how we use current technologies, so this is a fade diagram that's been applied to AI applications. So it talks about high consequence activities at the moment being better matched to humans on the basis that machines doing those kinds of activities we have a low trust in those because we've not implemented ethical AI approaches. And so the intention here is that humans are involved. The truth of the matter is, of course, is that we are using data models and algorithms for doing some very high consequence activities. For example, drug discovery, test discovery. You may have seen some of the research going on around COVID-19 testing and antigen testing, and I can tell you that some of the studies that have been used to validate antigen testing are done on very small sample sets indeed, like 68 tests in fact, and these are tests that have been manufactured at a very large scale indeed. So there are some real challenges going on there as well. So the truth of the matter is that we are using systems at the moment that have not been designed using AI ethics type approaches or ethics by design type approaches that may end up one day within an AI system, but are actually now impacting the world in which we live, because our governance, our regulations, and our custom and practice do not really fully address the implications of the use of these AI tools and techniques because they're so complex. These AI component tools and techniques because they're so complex. So we have this, we're in this very difficult situation. We need them, particularly in time of pandemic. We need to rapidly prototype systems, but yet the mechanisms that are not built into the tools that are being used in order to make the best kinds of decisions and really to try and understand the longer term implications of the kind of decisions that are being made off the back of those tools. So a short video here which talks about machine learning and human bias. This is from Google, but gives an indication of the kind of biases that we are concerned about.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? Nice. How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. Just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool in the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation, because technology should work for everyone.
Okay, so fairly straightforward explanation of bias. I'll just talk about a couple of bias types here. So the data that we're using, maybe in the development of technologies, is subject to what you might call a very wide range of biases. And the fact is that this is going on to develop tools and techniques and validate systems without necessarily ensuring that those biases are normalized out or removed in some way or taken account of. What I see in the work that I do is that sometimes data sets are really not adequate. They're not fit for purpose because there's a lack of access to good quality data set, but the work has to continue. And this is really quite problematic. It isn't just a problem for AI, it's in fact a big problem right now. And I think many of us working in research will understand that. But the question, of course, is that why isn't the focus being placed upon this? Why is it all about data and algorithms and tools and techniques for AI? Should it not be applied to the components that no doubt will end up in AI systems at some point in the near or far future? So just a bit of an overview again here. I mean, Wikipedia says there's over 100 different types of bias. There may be many more than that. I'm sure others will have an opinion, but the point is here that they come from a myriad of sources, and they are something that do need to be addressed. So what I'd like to do now is just move on to a bit of a conversation now. First of all, I'd like to introduce my colleague Agata Guskaya, who can, I believe you can speak now, Agata. And would you like to just introduce yourself before we get onto this section?
Sure. Welcome everyone. My name is Agata Guskaya from Trilateral Research. Thanks, Martin, for giving me the floor. Just a couple of words from me. I'm a human rights lawyer and I specialize in responsible innovation, particularly in the business context. Basically, I've been together with Trilateral Innovation for European projects, exactly in the context of responsible innovation, in different types of technology. So definitely AI, but also other technologies that we as PREFET also have identified as promising technological trends. So together with Martin, we've been in this exciting adventure, PREFET adventure.
Ah, perfect. I can see you, but I can't hear you.
You can't hear me?
Can't hear you. Oh.
You can't hear me?
I see you, but I can't hear
you. Can the others hear me? Because my mic seems to be.
I need to brush up on my lip reading here. Perhaps I can transcribe.
Go for it. Well, I hope that the others can hear me. So basically, we've been together with Martin in this exciting adventure, PREFET adventure, analyzing new technologies from SDGs, Sustainable Development Goals, and responsible innovation perspective.
Just give it a minute. We just try that one more time. Oh, okay. It's just me then. Is it? Oh, okay. All right. That's fine. That's fine. So you've introduced yourself.
Right.
Perfect. That's going to be difficult.
No problem. Just a quick intro. I will let Martin go forward. And guys, if you have any questions, I'll be reading them loud.
That's it.
So let's hope it works.
That works. Fantastic. Brilliant. Okay. Sorry about that. Okay. Let me just go back. So first of all, we're going to have a bit of a discussion about what principles that are being developed for future AI should be applied now to affect research data and software tools to ensure they're fit for purpose. So on this slide here, I have a number of points. On the left, we have the 7 key requirements that were produced by the European Commission's high-level expert group on AI. So it talks about human agency and oversight, so humans being involved in the loop, in the decision-making loop, technical robustness and safety, so speaks to that concept of verification, validation, privacy and data governance to ensure that any private data is used appropriately and with permission and is properly managed, and that data is maintained in that state throughout its for all the time that it's stored. Transparency is another thing, actually understanding why decisions are being made, and obviously the representation across a broad range of people is incredibly important as well. That's obviously a data bias issue, but also in terms of the consultation and regulation to make sure that nobody is disadvantaged unfairly. well, nobody's disadvantaged at all, in fact. So societal environmental well-being, so the broader implications of any decisions that might be made, and ultimate accountability, or of course that is rather a tough one if we are talking about systems that have levels of autonomy, and I'm sure the debate on that will rage forever about who carries the can when the system's made its own decision. So, Alex, do you have any particular thoughts on that as your background as a lawyer on the accountability side of things?
Well, from my perspective, it's quite interesting to think about. Of course, we can think about accountability, but it's particularly difficult from the technology point of view. And here, with some answers or some thoughts, actually, philosophy of technology and ethics of technology comes in. Particularly if we talk about design and responsibility of engineers and researchers, designers for their work. So it's not only, for instance, for the outcome, but also in case of the design as such. So it's very tricky, to be fair, from the legal point of view, but that's why we're talking a lot about ethics and human rights in the context of technology. And of course, law always comes later than technology. So that's why it's very, very challenging of making someone accountable from the legal perspective. But through using ethical principles and human rights perspective, we can already develop, especially technology that by design has principles, ethical principles and human rights in the design as such. So you design in the way that your technology respects ethical principles and human rights.
Yeah, that's a really good point. That's a really good point. I guess my challenge to that would be to say that we don't necessarily, not everybody thinks that the impact of ethics and human rights is something that applies to non-AI related things. We certainly should, but I think when we look at things like data sets and models that are used in research, it's not something that always comes up in that conversation. I think for AI related things, it certainly does, but I think for tools that we use or models that we use and have used for some years, I'm not sure that that's part of the discourse. What are your thoughts on how we might re-enliven that debate about existing systems? It always seems to be about the future, not about the present. Do you know what I mean? Oh, hello, 1, 2, 3. 1, 2, 3.
Yeah, I think if the question is towards me,
Yes.
Yeah, sure. I think that we have to also ask ourselves, like, who should be accountable then. So not only that we have laws for that, but why would we do it, in what way? Because of course we need instruments that have teeth, so that if something happens, we do have instruments like that. But I would also start from asking ourselves who should be responsible and in what way. So of course we need a regulation, but we have to ask ourselves, we can create any kind of a regulation, but if you can't really impose it, you can't really do anything about it to make it happen, to be applied, then in the end the legislation is inefficient and ineffective. So that's why I think it's very interesting how whole legal aspects of, for instance, regulating AI, but of course also other types of technologies comes in. And very interesting aspect is that most of the technologies that we see are developed by, of course, researchers, engineers who are parts of large corporations, but of course also startups, basically companies. And there's lots of initiatives around AI going on worldwide. Of course, also the EU level. So what Martin mentioned, this different like high-level ethics group on AI. But what is interesting, at least from my perspective, is to how actually industry starts to self-regulate. And why are they doing it? Of course, they want to be at the forefront of establishing the rules. And that's really, really fantastic on one hand, because they recognize that there are some challenges. It is important that they step in and they establish rules. But on the other hand, we're thinking about self-regulation and industry. So we have to think also of what kind of rules are there and to what extent they really respond to the needs and to societal values and needs. So there might be some clash of interests between self-regulation and regulation from the governmental level. So from accountability, we can think of this hard law when it's imposed by the government. On the other hand, we have self-regulation, and it's really about who should we regulate, to what extent, who should be accountable, whether it should be a company, a researcher, individual researcher, an engineer. So there are different levels, and I think this is what also makes it more tricky.
Absolutely, yeah, no, it is. It's extremely challenging, and I think it's always hard to do things after the event, or to recognise that maybe some research was biased. It's very hard to do that. People tend to like to move forward rather than to go back and go over old ground. Although of course it does happen occasionally. So on the right, on the slide here, we have data and data technologies that are currently being used. So clearly, data sets that I come across the use of what people are calling pseudodata or phantom data sets for machine learning systems. Well, of course, the whole point of that is that it's not anonymized, it's purely being created for a particular purpose. Well, of course, there's no way of knowing that actually whether that has any of the patterns in there that somebody might be looking for that would be present in real data. So the idea of using phantom or pseudo data is really problematic, because you can only create patterns in there that you know about in order to test systems. So the use of that rather worries me in terms of the development of systems, because it clearly by its very nature is not representative. Algorithmic bias, many have talked about that at Oxford. There have been a number of projects looking at algorithmic bias. The Unbiased Project is one, and there are many others around the world going on. So we know a little about algorithmic bias, but of course it may not always be obvious that algorithms are being used, and we may be subject to a discrimination in some way in our online experiences right now of algorithms that are discriminating against us in some unacceptable way, or in a way that we feel uncomfortable with. We just don't know. Now these algorithms may end up being components of AI in the future, but they're with us right now. So why don't we apply our principles that we're applying to AI on the basis that AI is the thing that powers the red-eyed robot that chases us down the road with a sawn-off shotgun or whatever? But the fact is that these algorithms are with us right now, and we are potentially being discriminated against, and our societal or the well-being of society is being compromised. But these techniques aren't being used right now, and we're just not applying, as far as I'm aware, the AI recommendations to that. It's always about the future, never about the present, and that concerns me. I think people say that AI is always 30 years away. Well, some representation of it is probably with us right now in terms of the specific AI or narrow AI. General purpose AI may never be achieved, or it would certainly be some time until it is. We don't know, but the question is what's with us now, and how should we be applying this kind of thinking to current problems? Because what will happen as there's a lot of talk about the use of AI for COVID-19 responses, I guess, in terms of the data analytics and targeting of measures and targeting of lockdown and targeting of high intensity testing programs, for example. How do we know the data that's being fed into that, or the algorithms that are being used, are not in some way biased and causing further divisions in society, which I'm sure we could all do without? The likelihood is that they are, of course. Well, why are we not applying these techniques right now? It's always off in the future, and I think we just need to get on with it. That's my personal view. So open it up to the audience. If anybody's got any other suggestions of areas that may need refocus or re-evaluation in terms of data and data technologies used in fact, please speak up now. I've put a number of examples there, but there are probably many others. So if anybody would like to put their comments in the chat, we'd be happy to consider those, but also to discuss those further on after Philip Bray's talk in a moment. So if you have any other suggestions for technologies that we think need to be re-evaluated, that would be great, beyond data, pseudodata, algorithms and models. Anyway, I think I'll leave you to think about that, because this topic will come up later on when we have our plenary session, about how we might move this conversation forward and actually do something about it, to take all of the great work that's been done on AI governance, but try and apply it to the world in which we live right now, rather than waiting for the future. I just don't think we can wait any longer, because these problems are upon us right now, and the impetus needs to be there to drive this forward. So I noticed that the attendee has gone up by 1, so I'm hoping that that's Professor Philip Bray, who's just joined us. Philip, if you have just joined us, if you could.
I have.
Wonderful. was that you just arriving, Philip? I saw the number went up. So. Fantastic, thank you. Great. So I'll move on to the next slide. So this is our next speaker, Philip Bray, who's a professor from the University of Twente, also the coordinator for the Siena project and many other things. So I will hand over to Philip to cover the ethical issues and analysis taken from the Siena project. Philip, if you just tap me when you'd like me to progress the slides, that would be.
Well, actually, can I use a different slide set?
Oh, you can, of course. Yeah, absolutely. Yeah, of course.
Yeah, just tell me how to do it, because I think I have a better one than you have there.
Okay, great, perfect. So how do we do that? I think I need to be able to make Philip the.
I think you need to make me the presenter.
Yeah. I'm just going to turn my webcam off for a second. So bear with me a second. Attendees. I can't actually see you on the list, Philip. So maybe you're already a presenter.
No, I'm probably not authorized to be a presenter at this point in time.
All right.
Hi, Philip. That's very strange, because you look like you're very incognito. Yeah. I can't see you on the.
It difficult. I can also.
I can't see Philip on the list. So. That's strange.
Alternatively, I just emailed you my slides right now, so that would be the other.
Right. We could try that. I mean, it'd be better if you did them, I think. But okay, let me just see if I can get that.
Hasn't gone through yet, though.
Yeah, I don't have any slides from you, Philip, I'm afraid.
They just went out, just right now.
Right. Okay. Is it an attachment, or is it a big file? Or?
Yeah, it's a big file.
Ah, okay.
5 MB.
If it's more than 30 meg, it might not come. Agatha, I can't see Philip on the attendees list. Can you?
No, I can't either. So as I said, it's Philip won't hack the system. It's hilarious.
Oh, I don't have the slides yet either, so we're a bit stuck.
I would guess they come in at any moment. If you use send receive, maybe it goes faster. Sorry about that.
Oh, perfect.
So maybe in the meantime, I'll start talking.
Please, yeah, if you would, you'd be so kind.
Okay. So thank you all for attending. And so this will be a talk on ethics by design. And I assume no prior knowledge from you. Tell me though if you already know a lot about it, but I'm assuming not, because it's pretty new as a concept. I mean, it has been promoted for the European Commission for a couple of years, but it has never really had a solid form that, like, this is how we should approach this. It's only recently that some organizations have started developing approaches in ethics by design. IEEE is currently developing an approach. They haven't finished yet. And we have been doing so as well in the Sienna project, which is an EU-funded Horizon 2020 project on ethics of emerging technologies. And so ethics by design is something that we developed specifically for artificial intelligence and big data, but something that can also easily be tweaked to apply to other technologies. So I'm going to focus though on its application to AI and big data, but I will also say what the general principles are and how they also apply to other technologies. So for AI, it's going to be an important topic in the new Horizon Europe program. That is, there will be a recommendation that projects incorporate ethics by design approaches. And then for other fields, it's less pronounced, but still something that I think the European Commission would look upon favorably. Okay, now we are switching to me now, or?
Yeah, so Philip, you can actually present now.
Okay, using my own, right?
Yeah, perfect.
Okay. So how do I select? Let's see. Which is actually the button for?
So if you go to the bottom bar on the right, there's a little there's a book, and next to the book is a tiny icon which looks like a projection screen. Can you see that in PowerPoint? If you open PowerPoint, so not in go to webinar, but go back to PowerPoint, because you're sharing your screen already. We can already see it.
I see.
Yes, if you go to the bottom right in your screen, the usual place for presenting. Yeah, and to the left a bit, left a bit, left a bit, left a bit, left a bit. No, right a bit, right a bit, right a bit.
This one, right?
Stop. Perfect.
Okay. And then get rid of this. Okay. So that's where we currently stand. So this is going to have a more prominent role in the Horizon Europe. And it's something that you may want to consider including in project proposals. So let's see. The central idea of ethics by design is that in the development of technology, design choices can have systematic positive or negative effects for the realization of moral values. So we already know this, for example, for privacy, right? We already have privacy by design. And we know that some designs are protective of privacy and others are harmful to society, to privacy. So we can actually make design choices that protect privacy or that end up harming it. Of course, those design choices are not the only relevant factor in predicting whether or not privacy will be harmed. It will also be how the technology is going to be used by people. But design has now been recognized as an important factor. So therefore, we can have the very possibility of ethics by design. That is to to consciously design for certain values. So ethics by design is a proactive approach to ethics rather than a reactive approach. So I think a lot of approaches to ethics are more reactive. So the kind of screening of ethics projects, for example, the ethics review, the research ethics committees, well, they're proactive in the sense that they occur at the beginning of a project, but they still react to a project proposal. So they react to a research design that's already there. Whereas ethics by design says, no, let's not react to anything. Let's simply say we want to design for privacy, or we want to design for fairness, or for other moral values. And how are we going to ensure that in our design, those values are supported? So it's a proactive approach, and it's a positive approach. It emphasizes positive values rather than worry about things that cannot be done because they're unethical. So how do you do ethics by design? You first of all need to be aware of the relevant moral values and principles that you want to support in your design. And we have lists of those. And I mean, there are universal lists, but there's also the particular design that you're making, and then investigating which values are relevant. Of course, it's very different if you're designing say a new bridge versus designing new software, right? Then other values are going to be important. For a bridge, privacy is not going to be important, but sustainability, for example, is going to be important. And for software, privacy may be very important, but sustainability may be somewhat less important. So the first step in ethics by design is to be clear on the relevant moral values that you want to support in your design. And so for AI, as you will see, and for big data, that's already somewhat clear because those values and principles have already been proposed by the high-level expert group on AI. So then second, the challenge for ethics by design is to integrate these ethical considerations into an existing design approach. So you already have your existing design approach, and the challenge is to include the ethics and design aspects into that, which is being done by operationalizing these moral values and principles that you got in step 1 within the existing design approaches. So that's in a nutshell what it entails, but I will now go into more detail. So what's very important in ethics by design is that you operationalize values and make them into design solutions ultimately. And that involves actually a 4-step process. You see 3 here. And then the 4th step is actually to come to concrete designs. So you start with values like fairness or privacy or control or transparency. Then you translate those into norms and then translate them into design requirements. And then based on those design requirements, you come to particular design solutions. So take, for example, this is an example from my colleague Ivo van der Poel from TU Delft. It's not at all to do with advanced technology. It's about designing a chicken coop. So we take a very simple example here. And you say, I want to design a chicken coop that upholds the value of animal welfare. So you want your chickens to be happy chickens, right? So that's a value. But of course, animal welfare is a very vague thing. How can a vague concept like that be used in a much less vague and more exact discipline that involves engineering design? Right. So you can do so by this iterative operationalization process by which you make the value more concrete and more actionable. So the first step then is to go from values to norms. What does animal welfare mean in practice, specifically for their living conditions, right? Because a chicken coop is about living conditions. So you need then to translate that value into norms with respect to living conditions. So one of those norms would be having enough living space, right? So there's more animal welfare if there's enough living space. If the living spaces are cramped, then animal welfare suffers. Another would be the presence of laying nests. If they don't have that, there's less animal welfare. And third and fourth would be litter and purchase. So there you already start translating your values into norms, into general recommendations of things that should be the case. But you're not then yet at the level of design, right? So you only have some very general norms or requirements. They're not really at the level of what you could call a design requirement. So that's the next step. The next step is to take a norm like having enough living space and making it into a concrete design requirement. So then you need to be a bit more precise. Well, what is enough living space? So it could mean, for example, that you have at least 450 square centimeter area per hen. It could mean that you have feeding throws that are at least 10 centimeters per bird. It could mean that you have a floor slope of maximally 14%, etc. So you come to rather exact design requirements based on the norms, which are again based on those values. And then the final step is, of course, to translate that in a specific design. So this is a very simple example to illustrate how ethics by design works. So let's apply that to ethics by design for artificial intelligence. So for artificial intelligence, the high-level expert group on AI, instituted by the European Commission, has already published its 7 requirements or 7 principles or values for what they call ethical or trustworthy artificial intelligence. They published this last year. And so they have 7 requirements. The first is human agency and oversight. So people should be in control, basically, and they should be free in their use of the technology. The second is technical robustness and safety. So the technology should be technologically robust and safe. Third is privacy and data governance. Fourth, transparency. 5, fairness, basically, diversity, non-discrimination, and fairness, they call it. 6 is environmental and societal well-being, and the 7th is accountability. So these are 7 requirements for ethical, trustworthy AI. So those are basically your 7 values that you can use in doing ethics by design for AI. So next, you need to know what the design process looks like and how it relates to your design methodology. So, of course, people have different approaches here, but what we did is we kind of broke down the design process into 7 practices that invariably the different approaches entail. So there's always going to be a process in which you specify the objectives of the design. There is always a process in which you specify design requirements. then there usually is some type of high-level design where you develop a high-level architecture, sometimes based on a prior conceptual model that you make. The high-level architecture that meets the requirements that you specified before. Often, certainly for data-intensive systems, you have data collection and preparation activities. And also based on your high-level design, you then do detailed design and development. And for software development, that will involve detailed programming and coding. And then you usually have some kind of testing and evaluation phase. So the challenge then is, for these different activities or phases, as you will, to be clear on what you need to do this kind of translational process, going from values to norms to design requirements to design. And of course, you may have your own favorite, more specific approach. There is CRISP-DM, which is a popular model for kind of big data design and AI. There's, of course, agile approaches. There's V methodology, used a lot in robotics, amongst others. So we think that these different methodologies, they all involve the 6 steps or six practices that we outlined here. And what we did for those 6 practices is we explained how to then include the ethical criteria. So let's take a look at that. So let's go to this phase where you specify the objectives. So you need to be clear on what are really the objectives of the design. What is the function of the product that I'm making? What should be its functionality? What is it for? What will it be used for? So one requirement here would be to evaluate those objectives against the 7 ethics requirements given by the European Commission, as well as maybe other detailed ethics requirements that may apply to particular types of systems or applications. We also developed a kind of a document on that specifies that. So this is to actually test whether the very objectives of a project, of a design project, are ethical, and then to kind of modify these objectives to ensure that you have an ethical project to begin with. So, I mean, usually, I mean, in 95% or 90, maybe even in 98% of the cases, that will be the case. There's nothing unethical about your objectives to begin with. But suppose, for example, you want to design a system that aims to manipulate people's emotional states, right? Or a system that collects personal information inside people's homes without their informed consent. Or a robot that can arrest and detain people. Well, then you're doing things that where the very objectives may be unethical or even illegal. So that's something you want to catch early, and that's where these 7 ethics requirements may help. Right, so that's a step to take early on. Then you may go on to say, okay, my objectives are okay, but I now need to specify requirements for my design requirements. You may determine also what resources you're going to use, what constraints apply to your design project. Here as well, you want to test those requirements and resources and constraints that you propose, test them against these 7 ethics requirements. For example, transparency is one of these 7 requirements. Now, suppose you choose deep learning as a technique, while you have a strong requirement of transparency for the particular design you want to do. For example, you want to have a legal decision support system, and people need to understand how decisions are made by that system, then transparency becomes an important criterion. But then if you choose right from the beginning to use deep learning, you may not get the required level of transparency. So that's why you want to test all the requirements also against these ethics criteria. And at this point, it's useful to do an ethical risk assessment to kind of anticipate possible future implications of the technology, of the design, and what are the potential ethical risks that may occur. And there are also methods for that that we refer you to. So a lot of the ethical work already takes place at those during those two phases, right, where you specify the objectives and the requirements. But then you're not done yet, because then you go to high-level design. Then you actually have to make sure that your chosen design solutions are appropriate operationalizations, include appropriate operationalizations of these 7 values, right? So just like with the chicken coop example, you want to make sure that your chosen design solutions are really provide a solution that supports the relevant values. So that's something you can test against by seeing if, by having that translation of values into norms and then into design requirements that you already had at your earlier requirements phase, and then seeing if those design requirements are actually met by the high-level design. And especially the values of transparency, autonomy, privacy, and fairness. Autonomy having to do with oversight and control. Those are often important at this particular phase. So you want to have a high-level design architecture that is supportive of privacy, that is supportive of fairness, transparency, and giving the user control. When we talk about data collection and preparation, so that's a very important activity for many systems. You want to make sure that data collection and preparation of data takes into account also these ethics requirements. And especially fairness and privacy are very important criteria here. Fairness because data collection and preparation could include algorithmic bias. It could include a process by which you, especially in personal data that is being represented or data about groups, social groups, you can actually introduce bias by uneven sampling or uneven selection or cleansing of data, and that's something you want to avoid. So we have recommendations in place for how to avoid algorithmic bias in the preparation of data. And the same goes for taking into account the privacy concerns. So then you go to your detailed design and development phase. So then here, even if your kind of high-level design passed confirmed to the ethics requirements, you still also want to check that for your detailed design. So you want to do another check here on transparency, privacy, fairness, autonomy as well. And then finally, in testing and evaluation, you want to do a final ethical assessment of your project outcomes. That is, does the design that has resulted, does that really live up to the values that you had as requirements from the beginning? So that will be just part of your regular testing and evaluation. So at this stage, but also right at the beginning of your project, we also recommend stakeholder engagement. That is to involve stakeholders in the process to learn about their ideas, their objectives, their preferences, and take those into account because they can also help better meet the ethical challenges in ethics by design. So this is an overview of the process. To support this further, we have a lot of detailed guidelines for how to do this. For example, we have guidelines for bias assessment in modeling for the high-level design phase. So how can you avoid bias in high-level design? So we have all kinds of guidelines for that. We also have some recommendations for how to deal with special types of technology or types of data. For example, building fully autonomous AI, or effective computing, or medical applications of AI, or sensitive data, or speech, text, and image analytics. So lots of special topics that we have in our documentation that could be supportive here as well. So that's, I think, already the end of my presentation. So what I've done is I have introduced you the notion of ethics by design as a new approach in ensuring more ethical projects. I've applied it specifically to artificial intelligence because that's what we currently have been developing it for. But you can, I think, already imagine how this similar kind of process could also apply to, say, construction engineering or biomedical applications. It's really the same principles, that you start with values, translate them into norms, translate them into design requirements, and then do kind of a proactive design that takes on board these values as kind of being included in the design requirements from the beginning. Thank you very much.
Oh, that's great. Thank you so much, Philip. That was really fascinating, and I'm glad you used those slides, because I think it was gave a really nicely rounded view of the deliverables on that project. So thank you so much. Very interesting. So,
my pleasure.
Should we take some questions on that before we move on? What do you think, Agatha? Should we do that?
Sure. I don't see at this point any questions. So you guys, if you have anything that you would like to ask Philip or us, but also comment perhaps about your own projects or your own experience with that projects, and exactly dealing with societal ethical aspects of your projects, please feel free to post them in the questions chat. Okay, so I think we'll give a couple of seconds to the audience. Philip, maybe I could ask you about the approach that you presented. I'm just wondering if someone from our audience would like to use the approach that you just presented, exactly about having these 4 levels of analysis and really applying this approach. How could our audience, how researchers could find this approach, and whether you have it somewhere on your website of some of the projects that you're doing, where could we find it?
Yeah, that's a good question. So currently we have published 2 documents in which we present ethics by design as an approach. One is in the Sherpa project, which is a project on AI and big data and ethics. And the other is in the Sienna project. I'm just going to give you the URL for Sherpa. First of all, so that's www.project-sherpa.eu. I can put that in the chat, right? And then also Sienna project. Great. And then in both, you can go to the publications, like here. I think if I'm still visible, you can see what I'm doing here. Actually,
yeah, we can see.
They're still visible. So go to publications here, and then I think, so in the Sienna project, we have, oh no, I don't see it up yet. I was told that it was up. There's a report 4.7, so it's not here yet. Hopefully we'll be here soon. And in the Sherpa, it's called deliverable D 3.2. So for download from their website. See if I can find it.
Philip, can I have a follow-up question?
You can see it here. Sorry?
I have a follow-up question. I was wondering whether you, whether this approach that you presented to us, have you applied it, or you know about some cases of other projects applying your approach in their, for instance, PET projects or even other types of technologies projects?
Well, like I said, it's pretty new, so we don't have a lot of applications yet. However, this ethics by design builds on prior approaches that are based on the same principles. We have value-sensitive design developed by Batya Friedman and her associates already, I believe, in the 1990s. And we have design for values. And so there already have been dozens, if not hundreds, of studies in which these principles have been applied. So the kind of basic principles of designing for values, I think, are already decades old. It's just that the current form that we're putting them in hasn't been extensively applied to cases yet.
Mm-hmm. Yeah, thanks so much for explaining. It's truly fascinating, and I hope that our audience, our researchers will also find it helpful and interesting for their own PET projects. And Philip, one more question. Do you think that this approach is equally relevant for technologies that we know about? So, of course, like technologies that we're developing currently, but also for future emerging technologies?
Yeah, I mean, I think so. It really depends on how much design it involves, of course, right? I mean, if you're mostly doing basic research, then I think these ethics by design has limited use. But at least you can already, in doing kind of the kind of ethical assessment of the objectives, the kind of ethical risk assessment, kind of the early stage of ethics by design might also apply to those kinds of projects. But the more you actually do development of new technology, the more then, of course, the ethics by design approach could be helpful.
Okay, thank you so much, Philip. I don't see any other follow-up questions.
I have one question for Philip, actually, if I may.
Sure.
Hi, Philip. So I think it was really very interesting indeed. One of the things we were discussing earlier was this idea that many PhET researchers are working on discrete pieces of technology which form part of bigger systems. Not many of them are systems in their own right, but they are components of bigger systems. So, and sometimes the final end use of these systems is really unclear. So even though they may have a particular efficacy in a certain area, how that fits into a much bigger system that people might use is often very unclear. Do you see any particular approach in trying to engage I think one of the things about many of the methods we see is that they're very much geared around specific use cases. This is what it's going to be used for, and we consider the ethical issues around that particular use case on its characteristics. But for many, it's really unclear what the use case is. In fact, they might have multiple. In fact, they almost certainly do have multiple use cases. And how might one address this, the ethical issues that cover a wide range of use cases? Because some of them may be conflicting. I know that's a difficult question, but
yeah, very good question. Well, two remarks about that. I think also when you're building important component technology or enabling technology, it's still it's useful to do this kind of ethical risk assessment, where you do explore the kind of possible applications and the ethical aspects. So you're less clear on those, but I think you can still explore them to some extent, and that requires maybe some foresight analysis, some scenario building or something like that, and kind of exploring this. And yeah, if you get an ethicist on board who has that kind of background, then the ethicist will be able to do that in collaboration with the engineers. But also separate from that, even components can embody values to some extent independently of the environment in which they operate, right? So you can already, so for example, a software program that's going to be a component of a software system can still be more or less supportive of privacy in the way it kind of is involved in the processing of personal information, for example. Or a component of a kind of physical system can still be more or less supportive of sustainability by, for example, being biodegradable or not biodegradable. So even for components, I think you can use this kind of ethics by design approach, but you will just, it will be more difficult because you don't have this immediate view on application, but many of these values could still apply.
Very good, thank you. Yeah, no, that's absolutely. Because just one other question. So obviously your talk yesterday talked about the idea of having a kind of an ethicist on the team, as it were, which certainly sounds like an interesting idea. But I speak as an engineer myself, so I know modern engineering courses do have ethics modules within them, but I do find that sometimes there is an issue of issues of language and nuance, that where communication between those schooled in ethics and those schooled in technical matters, sometimes information is lost in the communication. And I kind of hark back to C.P. Snow's seminal paper, The Two Cultures, where technical and humanities people speak a very different language, and they don't necessarily have the mutual understanding of each other's discipline to allow them to properly communicate. I just wondered what you felt about the lot of an ethicist in a team of techies, and how one might break those barriers down through education.
Yeah, excellent question. I mean, I think that those two cultures that you talk about from C.P. Snow, the alpha gamma people and then the beta people, I think the gap is less great now than it was, say, in the 1980s, because I think there's a lot more people now who have an interdisciplinary or multidisciplinary background. I think that at least the humanities and social sciences have become a lot more interested in technology than they were 20 or 30 years ago. I mean, 30 years ago, I think when you would look for social scientists and humanities scholars that were studying technology, you could count them with 10 fingers, right? And now there's many, many more. So that's a big change. And I think also the engineers are seeing more and more that they cannot avoid the kind of social and ethical issues with new technology that has become also very pronounced. So I think there's already a more potential for getting closer there. And I think there are now many ethicists that are used to kind of functioning in these science and engineering projects, and that are capable of bridging the gap. You have to find the right person, and also be willing yourself to engage in multidisciplinary dialogue.
Absolutely, yeah. I think I would agree with that. I think there's definitely much better awareness than there was when CP Snow wrote that paper. But I think but there's clearly more work to be done, isn't there, in terms of embedding this both in this discourse on ethics and the technical disciplines as well, that sometimes feel very far away from reality. Sometimes, as we talk about the fourth industrial revolution, where the speed from idea to implementation can be so much more rapid. The time for these issues to be addressed is that much less than it was. So I think we do need to make sure that engineers are schooled in these matters, so that they can have those thoughts themselves and at least have some idea of how one might address those during the early stages of development. So, but yeah, thank you so much. That was an excellent presentation. It was exactly speaks to the issues that we're trying to address with these two talks. So thank you so much.
Thank you.
Great. Okay. So Philip, are you able to stay with us for a little bit, because there's another, or do you need to?
I can stay for a few more minutes, but then I have other obligations.
Okay. No problem. That's fine. So let me just switch back the control. Just bear with me a second. Okay. So can you see my screen? Ethics by Design for Future and Emerging Technologies.
Yes, we can.
Just changed over. Okay, great. Very good. Thank you. Okay, right. So I just wanted to show a couple of videos here. This has been mentioned a few times, but this is it talks about the role of PhET and how this works, and really just speaking to this point again about how we actually go ahead and implement this, because obviously PhET research is going on right now, and these technologies will come to fruition in maybe not too far in the future. So whatever work that's going on now will have an impact on next generation of technologies, and if we're not actually implementing these kinds of techniques right now, it may be that those technologies are not as sound ethically as they might be otherwise. So just a quick video to talk about PhET itself.
It all starts with an idea, a new idea, a groundbreaking idea, perhaps even a risky idea. Ideas like this, given the time and space to grow, can change the world we live in. Ideas like this are what PhET Open is all about. PhET Open is an EU funding program managed by the Research Executive Agency for the very early stages of scientific and technological research. PhET Open projects are the seeds that will grow into radical new technologies. PhET Open funding helps new talent from research and high-tech SMEs to make a big impact on science and society. It also encourages them to become the European scientific and technological leaders and innovators of the future. PhET Open funding is extremely popular and therefore fiercely contested. Since 2014, over 2,500 proposals have been received. So what sets the successful proposals apart? Not all ideas are PhET Open material. Your proposal should be grounded in ambition and innovation. It will need to satisfy 6 specific PhET Open characteristics called gatekeepers. We want research projects with a long-term vision. Their impact should reach far beyond the near future. Your proposal must target a clear breakthrough in science and technology. technology. Novelty is key. We're not funding mere improvements of existing concepts. We look for proposals with foundational character. Will your ideas start a brand new technology? We like high-risk proposals. If successful, they become high gain for society. An interdisciplinary approach is essential. We need to see how you intend to break established collaborations and forge new relationships with diverse disciplines. If your proposal satisfies our gatekeepers, it may be right for a FET open grant. First step is to create an exceptional proposal and submit it to us for review by independent experts from academia and industry. FET open funding can help your ideas grow into something world-changing. FET open, novel ideas for radically new technologies.
Interesting. So that obviously comes from a few years ago, 2016. So before Philip goes, just one last question. So how do you feel that ethics fits into those gatekeepers that it talks about in terms of FET selection? How do you think it should be factored in to the decision about funding or supporting technologies?
How it fits into gatekeeping, you say?
Yeah, in terms of how, for example, the use of responsible innovation or ethics by design techniques within a project proposal could be considered within gatekeeping, for example, because it certainly doesn't appear to be in this video, does it? It doesn't really come up. It's not a.
Well, I mean, the way it functions now is that it's one of the criteria being used to evaluate projects in the ethics review, and it's also in evaluation. It's looked upon favorably if you don't just do the ethics review, but actually have some kind of special attention to ethical issues in the form of a task or work package. I've seen this often, not just in FET projects, but also in other projects that's looked upon favorably to pay attention to ethics or more broadly to responsible research and innovation, and that can actually get you some extra points. And I think it's especially important for FET projects since they are really about radical new innovation, which brings potential great rewards for society, but also potentially great risks. So to have an early assessment of those risks, including the ethical risks, and to take those on board in the development of that new technology, that would be a positive thing. Don't know if that answers your question.
It absolutely it does, and I think that's right to say that it's a good part of the process. So, and obviously, PREFET, part of cornerstone of the PREFET project has been to include responsible research and innovation within the evaluation of FET trends. It's a big part of what we do, and also the tools that have been created. The Pursue tool, which is intended to allow FET researchers to try and evaluate the longer-term implications of their research and to consider how one might address those within their research projects as well. So there are free-to-use tools available to support that, although they don't form part of the funding bid. We would try and encourage FET researchers wherever possible to use tools of that type to support their evaluations of the broader implications of their work. So that's great. Thank you for that. So next slide. So it's actually another. I don't think we'll do this actually. We've covered quite a lot of these issues already. So one of the things I wanted to talk about as we start to move into the plenary session is really thinking about this is just an example of the process of research through to implementation for 3 particular alternative energy generation technologies. And as you can see, the timeline from prototyping and R&D through to commercialization is actually relatively short, in some cases sort of 8 to 10 years. So if we're developing technologies now and the sort of ideas that we're talking about today are not implemented now, what is the world going to be like in 8 to 10 years time when we have technologies that are not necessarily as well understood in terms of their broader implications than they might be? I think with all the AI initiatives, the concept of regulations and guidelines and tools and rules and things are those conversations are well advanced, but some way away from embedded and ubiquitous implementation. It may be some time until they are universally adopted, and so we have this this period where we are aware that these issues exist, but we're not necessarily embedding behaviours to do something about them. And it could be the issues around these technologies manifest in the shorter rather than the very long term. So just making a point there about this idea of an accelerated idea through to implementation, how any delays in the implementation of AI guidelines might come back to bite us. So I would encourage an early adoption as far as possible. So other sectors are already applying this approach, and I just wanted to talk to you very quickly about it's actually a hackathon that we're actually running right now. It's going on in parallel to this event, not part of PREFET, but part of another project, but it's directly relevant to what we're doing here. So I'll just take you through the concept very quickly, and then we can have a bit of a discussion, hopefully, about how one might apply this approach to future and emerging technologies. So this is the scenario: solar power. So do the ends justify the means? I think people see photovoltaic cells as being definitely a part of our carbon neutral future. However, I'll show you a quick video. This something will help to illustrate the point. Okay, I don't think that's going to work. No, whatever.
What's astonishing about these rocks brought up from deep underwater is how incredibly rich they are in valuable minerals, especially the kind of things needed for renewable energy, which raises a really difficult question. If the world's going to go green, we may have to start mining rocks like these from the deep ocean.
So this is the challenge that we've set our delegates, and this is how we're approaching it. So tellurium is the mineral that's required. It makes photovoltaic cells much more efficient, apparently. So there are other options available, but this is one under consideration here. This is what it looks like. This is one of a number of other candidates. This is the location where the concentrations have been found. Apparently this tellurium is available from a number of places on dry land, but at very low concentration. And if we wish to deploy very large scale photovoltaic arrays to try and address climate change through reducing carbon emissions, then we are going to need a much richer source of tellurium and other minerals as well. What's been found is a location just off the West African coast in a pristine ecosystem which has been untouched by human hands, apart from the general pollution of the oceans, of course. And they're trying to make a case for actually mining this, and it will destroy this ecosystem, and it's a very large scale operation indeed. And so what we're asking our researcher delegates to consider is how one might balance the benefits of having much more efficient solar cells at a very large scale with the disbenefit of significantly damaging the environment for an unknown period, maybe forever, or maybe it's possible to recover. So that's the challenge that they are being presented with and working on right now. So this is a scenario. They're actually working for a commercial company. That commercial company has made a commitment to the Sustainable Development Goals. They've actually said we support these very publicly, and that's why they're working on that. That's something that is quite common with alternative energy companies. But at the same time, they're looking for options of how they can increase the efficiency of their sales in order to increase the market share that they would have, so they would make more money, but also increase the amount of carbon neutral energy or electricity that was generated. So the scenario is that you're a researcher, you're aware of these issues, you've done some work on responsible innovation during your studies, and you're now presented with this dilemma that you are working to enhance Sustainable Development Goal, so SDG 7.2.1, which is encouraging the use of renewable, higher proportion of energy consumption from renewable sources, but at the same time, a disbenefit in 14.2.1, which is the environment under the sea. So that's a particular approach that we've applied to a scenario. It'd be interesting to see how the delegates work that one out. I don't know yet because they're not presenting until tomorrow, but it's going on right now. But this is a particular approach we've tried, where you try to balance out the two and come up with some way forward. And they have been asked with looking at alternatives beyond just taking this approach to look at alternatives, and can they balance the pluses and minuses of those alternatives with the effectively the opportunity cost. So that's an approach to how one might try to address these ethical dilemmas, by presenting these scenarios and to compare them and contrast those. And it's a particular mechanism through workshopping it out. What does this mean for PhET? So if we were to consider all the things we've covered so far, we've talked about ethics by design, we've talked about responsible innovation, we've talked about how RI and ethics by design can be applied in different sectors. We've also talked about the fact that AI is some way off, general purpose AI at least, but in fact many of the principles that ethics by design RI have proposed are equally applicable to component technologies. They can be PhET technologies or other technologies. So this is really a question for the audience, for anybody who cares to respond. So how would we address, how would we apply all the great work that's been done on ethics and AI? There's a huge amount of energy that's gone into that, and a lot of thinking. So it is very much a current topic. But how could we apply this to address our current issues, things that are immediately with us? Should we, for example, broaden the focus of AI ethics initiatives, to broaden them out? Just don't talk about AI, but talk about the enabling technologies first. And AI is something that's an emergent property of those complex technologies. Secondly, should we encourage the development of regulation or regulators to take on that broader remit? So rather than focusing on this rather uncertain future of artificial intelligence that may or may not ever come into existence in a general purpose sense, should we actually start now by trying to broaden out those regulations? Maybe we have already. Perhaps there are adequate measures in place, but I suspect not. Should we actually encourage PhET researchers, or should even mandate PhET researchers to immediately adopt RI and ethics by design approaches within their project proposal? Maybe, as Philip was saying, that the mechanisms in place are there already, but as was also said, it is optional. There are some options in there, but of course, if you do choose to put forward a robust approach, you may get a better score and more likely to be funded, but it is an option rather than mandatory. And are there other options? So I'd just like to open up the floor to comments on that. There are approaches out there are being applied in other sectors, but should we be applying these now to PhET candidates, PhET trends, and PhET projects, or Pathfinder type projects? Should that be the name for these under Horizon Europe? So any comments, please?
I don't see any comments yet. maybe hard questions. So everyone is thinking. But I think it's it will be, yeah, I think that it will be really interesting to actually also ask our guests from the European Commission who are working on the new Pathfinder on exactly including the concepts of responsibility and sustainability, responsible innovation, or even types of SDGs and ethics in FET proposals. I think that's very interesting from the policymaking point of view. I was quite intrigued when I participated in the info days organized by the European Commission, and what I was really intrigued by was the fact that in terms of Pathfinder and FET, at least the speakers from the European Commission emphasize a crucial role of the application level. So as we know, it's this European interesting challenge that Europe is very, very good in research, and then the question is, how do we really move this research to the application level? And what was emphasized during this info days was that, okay, in the next Pathfinder, we actually really should focus on bridging research and application and industry. So I actually asked, what is the role of what would be the role, and how do they see the role of responsibility, ethics, sustainability, and human rights? And they all agree that yes, this is very important, and we will still strive for it. But I'm very curious from a practical point of view how it will be included in the new Pathfinder. So it might be worth to follow up, especially tomorrow when we have our representatives from the European Commission on asking about this. Yeah.
Yeah, it's a really good point. I mean, one of the things, I mean, I just talked about the UK. So we're running an initiative to effectively train the next generation of mainly ICT researchers to take on board responsible research and innovation principles. So there's a program where I think over the next 5 or 6 years, about 5,000 doctoral students will be trained. They'll be paid a salary, and all their fees will be paid in order to work on a wide range of technology disciplines under a government and semi-industry funded scheme, which is to value of well over €1 billion. So all of those students have mandatory responsible research and innovation training, all of them. It's actually a contractual requirement, and when we at Orbit, we provide a goodly chunk of that. So the idea there really is a sort of a bottom-up approach, where the figures tend to suggest that around 80% or so of PhD students in technology will end up in industry, and around the remaining 15 or 20% will end up in academia. But what they're trying to do is a ground-up approach, where actually you get these people to think about these things whilst they're doing their research, and so when they do end up in positions where they have an impact on how research is done or what research is done, that they are at least aware of these issues and are able to implement them should it be necessary or deemed necessary to do that. But that is very much a long-term initiative. It takes a long time for the doctoral candidates who we're working with at the moment to end up in positions of authority where they can affect change. We have what we call the College of Peer Reviewers, and those people are responsible for evaluating funding proposals, for example, amongst many other things. And there's a real reluctance to instruct those individuals to effectively to force them to use or to evaluate the responsible research and innovation approach within a project. I can understand why, because the whole point of having a community of very experienced people is that you trust them to represent, because there's a lot of them, a very broad church of opinion, and the funding authorities are very reluctant to force upon them anything in particular beyond what legislation requires. So it's an interesting kind of ground-up approach, bottom-up approach, where you try to change from within, but it's a very long-term project. So it'd be interesting to know what other nations have done to try and address this. Certainly building it into the funding process would be a good one.
Martin, I can tell you example from the Netherlands, for instance, exactly from the university, from Twente University, but also Delft, so the university that Philip represents, but also other Dutch universities. And that's quite interesting because engineering universities in the Netherlands, as obligatory courses, both in bachelor and master, have reflection courses, including exactly ethics of technology as obligatory courses. So that's definitely very interesting, and I think it's becoming more and more popular and known that technology has to be perceived in a broader sense, and not only from, okay, I want to build amazing technology and I want to do good, but even with good intentions, things can go wrong, because in the end, what we think is good may not be good for others, right? So what you said, it's however quite a long perspective, and then I think that what is also what we can look at right now is also what you said, that you understand why there is some kind of a resistance of, okay, why do I need to do it? There are other people who should do it. And I recall also having this discussion on, okay, that we are turning ethics and human rights into an administrative tool. And it's exactly, I think, Martin, what you touch upon is really not about making it an administrative additional burden on researchers who are already doing so much hard work on developing their concepts, but it's more about changing the mentality and seeing in ethics and human rights sustainability more opportunities than barriers. But there is like there is a need from both sides, like both policymakers, ethicists, of course, human rights people, to and of course engineers, to work together towards exactly expanding this this perception of technology.
Absolutely, absolutely. So I think it would be good to look across Europe to see the different approaches, but of course it takes a while for these things to manifest, to know whether they've worked. And I guess, like all of these things, I think you need a wide variety of approaches to test different environments, to test different ways of working, and to test with different disciplines as well. I think different disciplines look upon their role or their position in the world quite differently. And that's part of the change as well, isn't it? To recognise that as PREFET researchers, one way or another, we are creating the future. We may not necessarily realise it or even particularly want to do that, but we just are. It's just happening, you know. And it's sometimes hard to know which bit of technology will actually rule in the end, despite the ambition. Sometimes it's really not that easy to predict what will actually become the dominant technique or the dominant algorithm, and often we're very unaware of those which we are affected by. Anyway, I mean, there are some that we were aware of, like I think it's called PageRank, the original Google algorithm. I know they've moved on from that, but that obviously had a world-changing effect on how search was done and how many people discovered their information and many other things that they find important in their lives. And so, who knew that when that was originally developed in the ubiquitous garage in Mountain View, wherever it was, that would actually have such a huge impact on the world. And I'm sure there are many other anonymous, unknown algorithms which have had a massive impact on our world, and we're completely unaware that their effect is there, who created them, where they've gone, where they're going to, who owns them. It's very, very opaque indeed. We just don't know. Two guys or two ladies in a garage somewhere may be creating an algorithm which may utterly transform our world. We just don't know, because it hasn't been deployed at that scale yet. And they may have the ambition, they don't even yet know that they have the means to achieve that. So I think that kind of sort of wraps things up for now. I'm very happy to take questions from the audience on that. We've covered a lot of ground, really. I think we've explored ethics by design. We've tried to establish the relationship between responsible innovation and ethics by design, how it has an impact on PhET and how we might apply this. in our work and in our project proposals. We've tried to be a little controversial in places, and to make the point that maybe we should accelerate the implementation of ethics by design for AI into other areas, and that's really a point for a discussion, and rather than necessarily a proposal for adoption, because it does need to be yet proven fit for purpose. So with that, unless there are any other questions, I think we should wrap up the session, and thank you all for your attention.
Thank you, everyone. And guys, tomorrow we're going to have our last day of the conference, so you're more than welcome to join us. We will also present our roadmap, PREFET roadmap for top 20 trends that we've developed together with our experts, that hopefully will help you also to build new exciting proposals and projects around these trends. So we hope that it will be also helpful for us, for you guys, for future projects. Thank you, Martin, so much for presentation. It was lovely to hear also all the questions. And I wish you guys a lovely evening, a relaxing one before tomorrow, last exciting day.
Okay, thanks, Agatha. Appreciate it. Thank you. Bye. Bye.